am I missing? There we go. All right. Oh, sorry. It's because Connor is not. Oh, no, no, no. That's not it. Okay, everybody's there now. All right. I gotta say these are all kind of wimpy vectors, but that's okay. That's okay. They're all positive numbers. Oh no, sorry, Soren, you've got a negative in there. That's okay. That's fine. Let's keep it simple. Let's call your vector v. All right. So just Keely, I'm going to write in your space. So call your vector that you just drew v. All right. And now I want you guys to give me a vector. Write a vector. I'm going to type this here. I'm going to call it vector u that is orthogonal to the one you just did, v. Any vector u that is orthogonal to v. Remember how to do those orthogonal vectors? They're orthogonal if they've had their x and their y switched around and one of their signs changed, and it doesn't matter which one. All right, just checking everybody. Soren, yes. Grace, yes. Hannah and Connor, yeah. Ooh, nice sevens. Kaylee, yeah. And Darla, good. Joelle, Vino, good. Ian, if that's a negative 6.3 comma 1, then that's good. Okay, everybody's got a nice orthogonal vector. Okay, now I want you to write a vector w that is collinear to u, the one you just wrote. Collinear to u. Yeah, collinear means that it's just a multiple of it. So you multiply each of the components by the same number. And it doesn't matter what number. It could be positive, negative, fraction. It doesn't matter. But make it collinear to u. That's a good one, Grace. Hannah Connor. I feel like I should start calling you Hanor or Kana. Anyways, that's good. Ooh, Darla. Did you multiply by, what did you multiply by? Negative 20? Nice. All right, and Joelle, you multiplied by 3, good, and Fino multiplied by 2, and Ian, oh dear, Ian, you multiplied by 2, all right, I can read that, I can just barely read that, okay, And oh, Tyler. Oh, everybody, look at Tyler's. This is nice. This is good. What did Tyler multiply his vector u by to get vector w? -1. Is that okay? Is that collinear? Yes, absolutely. It's also something else besides collinear. What else could we say is the relationship between Tyler's U and Tyler's W? Yes, absolutely. Nice. Beautiful. Okay, here's my next question. I'm going to type it in the chat while I say it. Is W orthogonal to U? Is your W orthogonal to your vector U? What do you guys think? Ah, we have a difference of opinion. Excellent. Grace, why are you saying no? Why are you saying W can't be orthogonal to U? Exactly. If they're collinear, they must be parallel, right? And what does the orthogonal mean again? What's the angle between them if they're orthogonal? Yes, exactly, 90 degrees. So, sorry Tyler, but no. W and U are not orthogonal, they're collinear. So here's my next question. Does that make sense though, Tyler? If it's collinear, if it's parallel, it can't be perpendicular. Okay, next question. Is W orthogonal to V, though? What do you guys think? Oh, that was quick. Anybody else want to weigh in? What's the relationship between W and V? All right, it's unanimous. Yes, excellent. In fact, they are orthogonal. Why are they? How do you know? Like, how would you convince somebody that they are orthogonal? Joelle, what would you say? Convince me that W, your W, is orthogonal to your V vector. Same direction. Okay, you said it's the same direction. You mean W is the same direction as V? Or W is the same direction as U? Oh, you mean of U as U. But my question is, how do you know that W is orthogonal to V? This might take longer than what we can fit in a chat. What do you think, Soren? What would you say? Convince me that your W is orthogonal to your V. Ooh, that is very nicely put. Read that, everybody. W is orthogonal to a vector. Sorry, W is collinear, therefore parallel to something that we already know is orthogonal. Beautiful, beautifully said. All right, so now we all know, Soren, I'm going to borrow your spacer. We all know that the vector W is orthogonal, there's the symbol for orthogonal, to the vector V. So here's my next question. I want you guys to write one more vector, and right off the bat I want it to be a vector that is orthogonal to the original one, to V, but it's got to be different from W. Okay, give me another vector that's orthogonal to V. one, Kaylee. Oh, sorry, I was looking at the wrong one. I was looking at your W. Let's call this one, I don't know, U, V, W. Let's call it Z. Vector Z for zombie. Now that would be a cool name for a group. Zombie Vector. Am I right?
Neverat.
I'm going to suggest that to my son. So I'm looking to see vector Z that is orthogonal to vector V and different from vector W. So you kind of have to look at your V, flip and change a sign, and then multiply by something other than what you just multiplied by. Thank you, Tyler, for acknowledging my zombie characterization. Nice, Darla. Okay. Oh gosh. Soren, I'm gonna take your word for it. 22.79, 60.95. I'm gonna guess that you multiplied by 3? 2.65. Nice. As long as it's the same for both. And Grace. Okay, Grace is still doing hers. And Hannah Connor. Anaconda. That's what I'm calling it now. Anaconda, let's see. Where's your Z vector? Is this it? Let me know. Kaylee, negative 75. So you tripled and so, okay, good. So everybody flipped, multiplied, and changed the sign of 1. This looks excellent. 32. So Joelle, you multiplied by 4. All right. And Pheno. Oh, you divided by 4. Did you? Okay, no, sorry, you divided by... Okay, that's good. That's nice. That works. Ian, I can't tell. Have you written your zombie vector? Oh, there we go. So Anaconda, you, let's see, you multiply by 10. Okay, that works. That works. That will definitely be orthogonal. Okay, so I want everybody to go into the chat now and tell me how to create an orthogonal vector from another vector. How to create an orthogonal vector. What's the procedure? Beautiful. Very well explained. Switch them around. Soren, I'm going to borrow your space. So you take your XY, you switch them around, and okay, Joelle said change the sign of one of them. Yeah, change it. Doesn't matter which one, right? And then there's one more thing. Multiply, Hannah. Multiply both numbers by the same thing. So multiply each of the numbers by some number k. There you go. That's how you make an orthogonal vector. Cool. So now that you know how to do that, we're going to go backwards. By the way, all of this is introduction to tonight's VoiceThread dot product. It's going to make more that VoiceThread will make more sense to you tonight. I'm going to give you guys two vectors. I want you to tell me if they are in fact orthogonal or not. In other words, you're going to try and figure out if I followed the procedure you all just outlined to create my second vector. Okay, so here I go. Are they orthogonal? Of course, my calculator. How do you know? Convince me. And one other thing happened. You're right, Kaylee. One other thing happened. I switched, I changed, and I multiplied by 2. Yeah, that was pretty easy to see, right? Am I right? That was pretty easy to detect. Do you suppose it's always going to be that easy to detect? Of course not. Of course not. What about this one? Are these orthogonal? 3, 4, and 11, comma, negative 8.25. Not so obvious, eh? Ian, are you saying no for this one or the previous one? And Joelle?
This one.
This one? Okay. Oh, Grace is saying it. Oh, excellent. I have a difference of opinion. Yay! All right. Grace. Grace is correct. Grace, how'd you figure that out? Oh, sure. Now you're saying yes.
No, I calculated that on the calculator real quick.
I'm just bugging you. You changed your mind. Okay. So Grace, you got it right the first time. What did you do? What did you see? How did you figure it out? If it's easier for you to just turn on your mic and tell us how you figured it out, please do. Or right on the board. Divide 11 by 4, you get 2. Ooh, nice. And what made you compare the 11 to the 4? What were you compensating for there? Anybody else do what Grace just described, by the way? Divided one number by the other and then checked to see if it was the same ratio? Yeah, nice.
Yeah, that's how I figured out I was wrong.
Beautiful. Excellent. Excellent. Okay, you see? So you guys have to, think about how you created your orthogonal vector to check and detect if these are orthogonal. And that's what the dot product is all about. You're going to watch a voice thread tonight called Dot Product 1. And I'm hoping that this little exercise will help it make more sense to you when you watch it. The dot product is really just a quicker way to check for orthogonality than what you just did, what Grace just described, which is fantastic. Keep doing that if that makes sense, but dot product is just a quicker way. Beautiful. You guys rock, I gotta say. Okay, I'm gonna stop talking now and let you guys get some work done. So as you saw on your way in through Sakai, I have put the assignment sheets into week 4. They're called wait a minute, consolidation. How do you spell it? Consolidation. And there's 3 of them, 4.1, 4.2, 4.3. You're not doing all 3 of those. I just picked and chose certain questions from it, but that's what your assignment is made of. And your assignment, don't forget, is due next Wednesday, September 30th, by class time. So whenever your class is, the beginning of class on Wednesday, well, for you guys that's 9 o'clock, right? That's when I expect to have it in my either email, someone faxed it to me, or in your Dropbox. You can, if you're going to upload it yourself to your Dropbox. Before you get to that, I would highly suggest, though, that you try some of the visions questions on last night's VoiceThread on operations on vectors, page 37. This is all in the work guide, but I'll just write it here. 1 CEF, the rest of number 4, because you've done some of number 4 already. Number 6, 12, and 13. That's practice on operations on vectors in all the different forms. That's practice where you check the answers, as opposed to the assignment where you can't check the answers. And then tonight, you've got, like I said, you've got that VoiceThread dot product 1. It's a pretty short one. And like I said, it's going to make a lot of sense after what you just did today. Questions, thoughts, problems, confusions, feelings? Okay then.
Well, Miss, I can't really read your writing, Miss.
What? I've never heard that complaint before. Yes, I have. Okay, then you know what? Just look at the, I'll try and write this as clearly as possible. Try and read, it's all in the work guide. Alright, for this week, which is week 4, and everything I just said is on September 24th and 25th. Okay? That's typed, so that should work better. Okay, send me a private message, everybody. Tell me where you're starting and get to it.